Now our producer Janina Schwanecker is off to Wairarapa for a treasure hunt of a different kind, as part of a nationwide study looking at the causes of a common disease impacting livestock. She's wandering the hills in search of little green-brown nuggets alongside sheep, beef and deer farmer Paul Crick.
It's a bit of a walk through here, right? See what we can see. Done a lot of things, but I never ever thought I'd be called a poo hunter. They tend to sort of camp, they like camping in the spots, so I sort of, boom, here we go. As always, fresh is best.
So you're looking for nice, good colour, good moisture to get those signs of freshness?
It sounds like a face cream or something, doesn't it?
While Paul and I are enjoying a good chuckle over our current task, collecting faecal samples from his mob of sheep, it's actually for quite a serious endeavour. Paul is one of 290 farmers around the country, taking part in a 3-year study by Beef and Lamb to better understand facial eczema.
Facial eczema is caused by a toxin in the pastures, predominantly through from now late October, November, and through to the end of May. It loves warm, moist, humid conditions is what it really thrives in. So it's in the sward, animals come along, graze the pasture, ingest the toxin. Essentially it affects the liver and causes the visual effects look like really bad sunburn, peeling on the face. So those are the clinical signs, and clearly what we can't see is the subclinical signs, and those are the ones that can affect our production without us actually seeing. And so what we're trying to do here is build up a bit of a database and knowledge around where the spores are, and hence that's why we're collecting the poo samples, because we'll find them in the poo samples themselves, and then so we can build up a bit of a map as to where it is and at what times it is through the main season.
Grabbing your bits of kit.
Yeah, so we just need to put our gloves, and so these are just the little bottles that we're going to put the specimens in, the poo samples, and then we just basically bag it up, box it up, and then send it off to the lab.
And have you been with the trial right since it started? Yeah,
we did. This is our 3rd season. In our 1st season we started, and look, the results came back and we had nothing. And I thought, oh God, this is a waste of time, because we're in the Wairarapa, we kind of know that FE is present, but we don't know how prevalent it is. And that was part of the motivation for doing this and being part of the trial, was to actually understand a bit more about, is it a factor, is it a big factor, how can we manage it? So yeah, we're involved, and we took our last sample right at the end of May, and I thought, God, this is, nothing. It came back, we had a spore count of over 100,000.
Wow.
And that really made me think, because I thought, well, we can't see it. I don't know that it's there or not there. I don't know.
Unless you've got sick animals, you'd have no idea.
Unless I've got clinical signs, right?
Yeah.
And so I don't know if it's in this part of the paddock, but not in that part of the same paddock, right? This clearly is an issue here. And so how do I then manage that? And so that then led us into thinking about our farm system, thinking about our genetics and what we do there.
Apart from the obviously awful animal welfare issues, facial eczema is also a problem which costs New Zealand farmers about $332 million each year. This study is focused on sheep poo, but facial eczema also impacts cattle, deer, goats, alpaca and llama. Already the study's provided valuable insights, detecting facial eczema causing spores in parts of the country where it was not previously known to be.
In the 1st season, there was 12 farms involved in the Wairarapa. All 12 had spores come through in the poo samples. In the 2nd season, there was again 12 farms, but one farm went through without any spore counts, whereas the others did. And one of those 11 that did have spore counts, one of them had clinical signs of FE as well that they noted in their animals. So it's here, down through the North Island, and they've actually found spore counts right down in Otago.
What happens if a farm does have really high counts of facial eczema and they start to see clinical signs of it? What options are available to them, really?
Shade is really important, so to get them out of the sun. Zinc is another method in terms of treatment, mainly orally, but they last for about 6 weeks, I think. So that way you've got to keep bringing the animals in through that peak period.
I suppose so. One of the other management tools available to farmers then really is to try and breed or bring in facial eczema tolerant genetics.
Yeah, look, 100%. And look, conflict of interest. We breed highly tolerant FE rams. So, we saw it coming, been here on our own account since 2019 and thought, we've got to try and front foot some of this stuff. And so it's also part of that animal welfare. So how do we breed an animal that has got a good level of tolerance to FE? Good genetics is one tool in the toolbox, and there's other tools that that farmers can use. We've noticed that through blood testing, etc., you can build that tolerance relatively quickly. It's a relatively highly heritable trait, and so farmers can make good progress quickly.
Speaking of progress, Paul and I have managed to find our last sample.
Oh, those definitely look fresh. It's a bit like an Easter egg hunt almost, isn't it?
It is, and that one there, it's still warm.
So very, very fresh.
Fresh out of the oven, that one.
Into the tub?
Into the tub, and we want a reasonable specimen size. We don't want just a couple of little, little smarty pellets.
Yep.
We want a good chunk, so to speak. Yeah, so that's a good one. Good colour, nice and soft, fresh still. Perfect. Cool.
Done.
From the hill paddock in Wairarapa, I'm off to the lab in Palmerston North to meet Awanui parasitologist Sarah Riddy. She and her team process up to 260 samples like Paul's every fortnight during the peak period.
So our samples come into the laboratory individually packed, so each of the farmers get a kit sent out each year. They come in these nice fancy boxes, and the farmers do a fantastic job of packing them. They generally put 5 samples in each bottle. They put them inside the plastic bags, inside the biohazard bags, and they send us a really good submission form, which is supplied by Awanui and Beef and Lamb. It's got all the details on there that beef and lamb require, so the breed, grazing, height of pasture, type of pasture, things like that. What we do at this point is we assign an individual laboratory number to each of our cases. This is a point of ID that goes the whole way through the laboratory. It means that we can identify each individual sample to each individual farmer, allow us to give out the results as well as track for MPI purposes. So that's what we do at this point. And then
Those little bottles with yellow lids.
Yeah, little bottles with yellow lids, yeah. And then these go through to the laboratory like such. We'll head on down. And they keep us right at the back.
Is that because you're one of the maybe more biologically hazardous?
More smellier of
More
lads.
smellier, yeah.
Smellier of lads, yeah.
Parasitology, here we are.
So each of our samples come into the laboratory. We have an individual worksheet for each of our samples. That means that we can record all our data and everything onto there. Each of the farms send in 10 samples per mob, and that allows us to give sort of an overall pool value, so that it gives them an idea of what's happening in the mob rather than what's happening in an individual animal. And that's great for surveillance data, which is what Beef and Lamb are trying to collect. So from each of the samples, we weigh out 1 gram per sample. So each sample is weighed out to 1 gram.
Exactly 1 gram.
0.8 to 1.12, and the reason that we hold a tight volume in that situation is because we're trying to gum up to 10 grams at the end, because that's our dilution point, but also because we are trying to give an overview of the mob, so we're trying to do an even proportion from each of the samples that are collected. It's the same as what they do when they do something like a larval culture. It doesn't need to be an exact science, but the closer we can do it, the better off their value.
There is definitely a faint smell of sheep poo. I imagine, they have to make their way to the lab, so there's possibly a few days transport and things like that as well. So they're a little bit whiffy when they arrive.
By the time you leave this laboratory, you won't even smell it. It'll be part of your second nature. And so each sample is tested together as a pool, but we take some from each sample as such. So it's our end volume of 10.
10 grams, yeah.
10 grams, cool. And then from here, what we do is we add in 90 mils of water, and this gives us the dilution factor of what we're trying to achieve. And then these are spun for 5 minutes. This allows the sample to distribute evenly. It's the same procedure we use when we do fecal weed counting or anything like that, except for the fact that this has got water, so it's not a float. A fecal weed count will use salt, this uses water, so there's no need to float the spores out of this thing. We can get it out from that way. And from here we take a sample We load it directly onto our hemocrypt chambers. We use glass hemocrypt chambers, which is slightly different than what you'll find in a vet clinic. The reason we use the glass ones is because of the volume we do. There's less damage to the glass things, they're calibrated, and that means that they stay the same with every single test that we do. And so what we do is we load it onto the chamber, it's evenly distributed, and we look down the microscope and there's a grid on the microscope, and we are looking for those, which are little spores.
Oh, I can see, yeah.
This is not a positive from this year, this is a positive from last year, because we don't actually have any positives this early in the season, but this is one that we've pulled out of the -80 from the previous year. So we count that whole grid on both sides, and that gives us our spore count, and from there we can work it back.
And is that spore count done manually? You just
Manually. So one thing parasitologists are really good at is microscopy. We spend our whole days on a microscope counting. So we're very good at numbers and we're very good at microscopy. And from here, what we can do is we can work out what they call a dry matter. And so we take a portion of the sample when it's evenly spun, we take 20 microliters and we tip it through a tissue. And this removes the moisture. We make this into a bit of what we like to call a poo dumpling, I suppose, is a good sample of it. This removes all the water. And then we incubate that tissue overnight for 24 hours, and then we can weigh that tissue, and that gives us a dry weight that we can calculate back. This is why the farmers will find that sometimes when they get a whole bunch of negative or unseen results coming through, they come through quite fast, but when they get a positive sample, there can be a bit of a delay in the results. It's because there's that extra additional 24 hours of testing that we need to be able to work out that dry matter conversion. So once we start getting lots of positives on farms, it can slow the result turnaround time a little bit. So from here, what we can do is we can work out the dry weight count by minusing the weight of the tissue from whatever the weight of the sample was, and then we can convert it by the dilution of the slide, and that gives us our dry weight calculation back, spores per gram, so that they can be sort of correlated back to the pasture. It gives them the same sort of result as their pasture counts, rather than just what the spores were in the faecal sample that was tested here.
Sarah Riddy from Awanui Lab in Palmerston North. Janina also spoke with Wairarapa sheep and beef farmer Paul Crick from Glenside, and good news, the latest results from his farm found no spores. Now, Beef and Lamb is still looking for more farmers to take part in the final study. You can find out more information on our webpage or in the show notes.